Example 5 says, for the function f defined by f of x, find the following values. So this kind of piggybacks on our function notation as far as A and B go, and then C and D are going to set us up really nicely for the next part of this lesson, which is our difference quotient. So part A wants us to find f of -3. So remember, this is my x value. So we're going to take this function here, and everywhere that I see an x, I'm going to substitute in what x equals -3. So we have 5 times -3 squared plus 2 times -3 plus 1. When you substitute in, please substitute in with parentheses. Okay, now you can put this in your calculator just the way it is right there, but this isn't that bad to do by hand. Exponents first, so I'm going to do 5 times 9. That's going to give me a -6 plus 1. Here we get 45 minus 5, so this equals 40. Okay, but you can put this in your calculator just like that if you want. So when I get f of -3, we're just simply substituting in that value into our function. What do we get? This should look kind of familiar. This is how we checked if a function was even or odd when I had f of -x. So again, this is representing what x equals. So same thing, where I see these x's, I am now substituting in what x equals, which is -x. So we have 5 times -x squared plus 2 times -x plus 1. So check your signs. -x times -x is positive, so this gives me 5x squared. Positive times negative will make this a minus 2x, and then drop down your plus 1. So there is that. And so is that just last lesson? Yeah, last lesson. Is this even, odd, or neither? Well, it doesn't match because we have a positive and a -2, so it's not even. And it's also not the opposite. For it to be the opposite, this would have to be negative, negative, actually, all negative coefficients. And we have one negative here. So has a little tidbit. This is neither. And what I mean by neither is neither even nor odd function. Okay, now this looks very similar to this, but now I want the negative version of my function. So now that negative goes out front, and I need parentheses around everything. $5x squared plus 2x plus 1. And so distribute. We're going to get -5x squared minus 2x minus 1. So again, just talking about it, that's why it's neither, because that's what it should equal to be odd. And so even though these notations are the same, I want to make it very clear that these are not the same. And then lastly, f of x plus h. What is in parentheses represents my x. So I am going to replace both of these x's here with what x equals, and x equals x plus h. So now we have 5 times x plus h squared plus 2 times x plus h, and then drop down your plus 1. So this was 5x squared, now it's x plus h. This was 2x, now it's 2x plus h. to set us up nicely for in the future, we're going to take our time on this x plus h quantity squared. And I have this over here. X plus h quantity squared does not equal x squared plus h squared. When we have x plus h quantity squared, what that is x plus h times x plus h. When you're multiplying two binomials together, FOIL. So x times x is x squared. X times h is xh. And so that is x times x and x times h. So now we need to do h times x, which it doesn't matter the order these are wrote in. So I'm going to put xh and then h times h, which will give me plus h squared. These middle two terms are like terms. They are both an xh and an xh. So if I have one xh plus one xh, that is going to give me x squared plus 2xh plus h squared. So we have here 5 times x squared plus 2xh plus h squared. This right here is now this right here. For my students taking this online, you can use your notes, right? Not a big deal. For my students taking this on campus, you have 3 options. You can either memorize that x plus h quantity squared equals x squared plus 2xh plus h squared. You can memorize this process and come over here to the side and expand it out, FOIL it, and combine it. Or if you want to put on your note card, x plus h quantity squared equals x squared plus 2xh plus h squared, that's fine too. But it does not equal 8x squared plus h squared, because then we lose out and we miss that middle term of that 2xh. Okay, continuing on. I'm going to distribute this 2 to everything. So we have plus 2x plus 2h, bring down your plus 1. And then my last step is to distribute in this 5. So we have 5 times x squared plus 10xh plus 5h squared, and then drop all these down. Plus 2x plus 2h plus 1. This is my final answer. We have 6 different terms here, and none of them are like terms. You have an x squared. These aren't x squareds. You have an xh. None of these other ones are xh's. You have h squared, no h squared, x, no x, h, nope, constant. So that is as final as that can get. Now next lesson, or not, I mean not next lesson, next video, we're going to go over the difference quotient. And the difference quotient is f plus, okay. Next lesson, we're going to go over the difference quotient. The difference quotient is f of x plus h, which is what we did right here on D, minus my f of x, which is what we did right here on C, all over h. So if you do not understand and did not understand part C and D, rewind this video and make sure you fully understand part C and D, because we're going to do both of these together all over H and a lot of simplifying. It's going to be a lot of algebra. So make sure you know part C and make sure you understand part D before you move on to the next lesson.